So we're looking at classifying triangles. This is something you would have done previously as far as understanding that you can classify triangles by its angle measures and by its side measures. We call an equal angular triangle a triangle who have all congruent angles. Similarly, an equilateral triangle has all sides congruent. So all angles congruent is equiangular, all sides congruent is equilateral. Lateral means side. We also are going to be looking at isosceles triangle. And I draw your attention to this piece right here because I think it's so important. It says at least two sides congruent. But we often miss that at least two, which means it could be all three are congruent, and it's still called an isosceles triangle. Therefore, an equilateral triangle is technically an isosceles triangle because it does have at least two congruent sides. We'll talk about some of this other stuff in another slide, so I'll wait on that. A scalene triangle then, at the bottom here, is a triangle that has no congruent sides, no sides congruent to the others. So we could talk about how we classify cars. We could classify cars as Chevrolet, Ford, Honda, Lexus, that way. We could classify them by sports car, coupe, minivan, SUV, that kind of thing. We could classify them as red, blue, and white. There's probably some others that I'm not thinking of right this second, but in other words, there's different ways to do that. Here are some cars that I took pictures of in the past, and I think this one here is worth about $200,000. That was in Vegas somewhere. Here's some more pictures that I did not take, but these are trucks. They're all trucks. They're quite different though, and so classifications can be interesting. So how do we classify triangles? We've already said we can do it by sides or we can do it by angles. And we will look at the specific types here. In fact, here you go. This is classification by angles. You're probably not surprised at all to see these four different types. I mean, if nothing else, we should probably know already about a right triangle and an acute triangle. A right triangle has one right angle. An acute triangle has all three acute. Now remember what acute is, less than 90. So technically, a right triangle has two acute angles. But we don't call it an acute triangle because it's got this special guy right here. It's right angle, which makes it a right triangle. Only when all three are less than 90 do we call it acute. Further then, we have the equiangular, which we've already discussed, means all angles are congruent, and therefore they're all acute. And to be honest with you, they're all 60. Because we know they have to add up to 180, and if there's three congruents that add up to 180, then they're all 60. And then we have this other one, this obtuse angle. Obtuse angle means there's one angle right here that is bigger than 90, because that's what obtuse is. Turns out the other two are acute, but we don't call it acute. That's reserved for this one. It has all three acutes, less than 90 angles. So it says classify as acute, equiangular, obtuse, or right. Well, I hope you can see that it is acute technically, but it is more specifically equiangular. So you can see that's what we got here. This one classify the triangle as acute, equiangular, obtuse, or right. Well, that's acute, but that is obtuse, making the answer obtuse. In other words, the most special, that's what we're going to call it. So it's obtuse. You may notice here that when you look at all three of those, they do add up to 180. So it says the frame of this window design is made up of many triangles. Classify ACD. Now, when they say many triangles, most everybody sees 4 right away. 1, 2, 3, 4. Most everybody sees the 4 right away. But they mention A, C, D, which is what I labeled as angle or triangle 2. I just want to hit you with this before we move along, though. Did you see this triangle? Because it wasn't one of the 1, 2, 3, 4s that I labeled. Now, that's not anything to do with this specific problem. That's the blue thing that I had outlined. But I want you to see that that's how that works. Like, sometimes there's more than you see. It's like the bird in the tree. Anyway, so when you look at this blue triangle, hopefully you see that this angle right here is greater than 90, meaning the triangle is obtuse. Obtuse. Now we have triangle ADE. ADE. This triangle. As you can see, that's another triangle that you might not have noticed when we labeled the 1, 2, 3, 4. That being done, since this is a window, we better hope that that's a right angle down there in the corner, making this a right triangle. Now we can do some pretty interesting things. And one of the things that I talk about a lot is the importance of us to make connections and know relationships. And that's certainly going to be true right along. And we have to pay attention to details. And we're going to see that a lot in this chapter. We're seeing it in this section, but we're going to see it a lot in this chapter. So it says, classify triangle XYZ. Now that's the big triangle, right? Because you see the 2 smaller triangles that make up the big triangle. So there's 3 triangles there. The 2 smaller ones and then the whole big thing. When we look at the whole big thing, you see one angle's 50, one angle's 40, but how much is this angle? It's 90, making this a right triangle. Classify triangle ACD. They didn't label this, but I imagine they mean the whole thing because that's the only triangle I see. And since all 3 angles are acute, less than 90, the answer is acute. So that was angles. Now we can talk about sides, which you've already done, actually. If all sides are congruent, it's equilateral. If at least 2 sides are congruent, which could be 2 sides congruent or all 3, it's isosceles. So this technically is an isosceles triangle. It's a special type of isosceles where the third side is also congruent. But if there are no congruent sides, we call that scalene. Now, I want to come back and look at the isosceles. The standard isosceles triangle would look something like this, where you have your base angles. Here's your base, and your base angles are in these bottom corners, and you have these legs, and you have the vertex. Okay? The vertex is always at the place that connects the 2 legs. The vertex angle. The base angles are congruent, and we'll talk about that later, but they're congruent. That's just how that works, which is pretty neat. Now, this is what I'm going to call a generic isosceles triangle. I say that because they don't always come with the base on the bottom and the vertex on the top. They just don't always come that way. Sometimes they come flipped around sideways, and the base is on the left or the right or the top or whatever. But what we have here, and this is what I want to really make sure you see, the legs are the congruent sides, no matter what. The legs are the congruent sides. So where the congruent sides meet, that's called the vertex. So where the congruent sides meet, that's called the vertex. The angle or the side opposite that is called the base, and then those two are the base angles. Okay. So it says the triangle truss shown is modeled for steel construction. Classify triangle JMN, triangle JKO, and triangle OLN as equilateral, isosceles, or scalene. So let's begin by looking at the J. The JMN. The JMN. Looks like the whole scissor truss. Or not scissor truss, just a triangle truss. Looks like the whole truss is triangle JMN, sorry. And it appears to me that this angle here is greater than 90. So that one, we're doing sides. We're doing sides, not angles here, sides. Are any of these sides congruent? Maybe. I mean, without measuring, it's hard to know. But if this side's congruent to this side, then it's isosceles. If those two sides are not congruent, then it's scalene. Let's move on. Within the same problem, and let's look at triangle JKO. JKO. I really don't think that JK and JO are congruent by looking at this picture. I really don't. And if they're not, then it's scalene. We can measure it, like get something to measure it with. And then OLN. OLN. OLN looks to me like those two are congruent. Like that's the vertex angle. And this is the base down here. That's what it looks like to me. If that's true, then it's isosceles. Now we'll see if we're right or not, and then we'll come back and talk about whatever we missed. Well, they say that JMN has no congruent sides, therefore it's scalene. JKO has no congruent sides, therefore it's scalene, which we got that one, we missed this one. And then they tell us that OLN has all sides congruent. I didn't see that either. And so it's equilateral. So let's go back and look at it. So they're saying that the whole blue thing here has no congruent sides. We thought maybe these two were congruent, but they're saying they're not. The scalene, the red one, we got right. We said it's scalene. And then we marked this congruent to this, but they're saying it's also congruent to this, which is equilateral. Hard to see just by looking. And remember, I've told you, jump to conclusions, it's a scary thing. So let's go back to this picture, but this time we're going to classify this picture evidently by sides. So we have triangle ABC, which is this one. I'm pretty sure it's not right, so I want to mark that out. And I think that's at least congruent to that. Maybe that one's congruent also, but I think it probably isn't. And if just the two are congruent, it's isosceles. And that's the answer they have. But sometimes those are ambiguous. I will try not to give you ambiguous questions, particularly when it comes to testing, because I don't want you sitting there guessing. You need to be able to know one way or another. It says if point Y is the midpoint. All right, they're saying this is the midpoint. If that's the midpoint, little children, then this is 4.2 and this is 4.2. Because the whole thing, as you can see, is 8.4 units. Inches, feet, yards, miles, we don't know what. So they've asked us to classify triangle VWY. VWY. Okay. It looks like that this one and this one are definitely not, because it's 4.2 and 4.5. The question is this congruent to this? How would you know? How could you know if those two are congruent? Well, since this is a right triangle, O Pythagorean would have to work. So let's call this, let's call it A for the purpose of discussion. So C squared equal A squared plus B squared. C is the hypotenuse, which is 4.5. A is the one we're looking for, and B squared is 4.2 squared. Now let's see where this takes us. I'm whipping out my good old trusty calculator here, and I'm doing 4.5 times 4.5, which is 20.25. We don't know what that is. And then I'm doing the 4.2 times 4.2, which, believe it or not, is 17.64. So that means A squared is equal to 20.25 minus 17.64, which is 2.61. If I take the square root of 2.61, I can find out that A is equal to 1.6, so on, approximately. So they're not congruent. Let's see what they've got. They made the same assessment that we did about the 4.2s. And since all three sides are different, then it's different. Okay. That's what we said. Hopefully these get a little clearer, but you never know. Sometimes they do and sometimes they don't. So, again, they tell us that C is the midpoint. So that makes that 1.7 and that 1.7. And they want to know about triangle ABC, which is this one. Well, they have marked for us that those two are congruent. They're not the same as the 1.7, but they are congruent to each other. So the answer is B. Isosceles, two equal sides. Find the measure of the sides of a isosceles triangle, KLM for base KL. So this is the base. And these are the two congruent legs meeting up here at the vertex. Just works that way. We need to see it that way. It's just how it works. Now, because the two legs are congruent, I should know that 4D minus 13 is equal to 12 minus D. That's my equation. I did not use that because it didn't have anything to do with the two congruent legs. So I move the D across, I move the 13 over, it becomes 5D equal 25. D is 5. Did it ask me to find D? It says find the measure of the sides. So I need to find the measure of all three sides. So just looking at KL, if D is 5, you put 5 in there, it's 11. Looking at KM, you put 5 in there, you get 20 minus 13 is 7. And then LM, you put the 5 in there, and you get 7, which was good because we got 7 for that, 7 for that, 11 for that, and the two that were supposed to be congruent are. Great. Nice confirmation for us. So they found their D, they plugged their D back in, and they found the same pieces of information that we did. Last problem. Find X and the measure of each side of an equilateral triangle ABC if such, such, such. I want you to notice that they did not offer us a picture here, but they did tell us it's equilateral, so I'm going to draw one. And it kind of doesn't matter if it's exact, but there's three sides and it's equilateral, so they're all congruent to each other. They do tell me that, and I'm drawing this because you got to get used to drawing. They do tell me that this is 6x minus 8. They tell me that this is 7 plus x. And they tell me that this is 13 minus x. Now, I kind of didn't need to draw it to know that these sides are congruent because they told me that when they said it's equilateral, that means they're all congruent. So what I got to do now is pick two. Any two, doesn't matter. Pick two and make them equal to each other because they're all three equal to each other. So pick two. Any two, doesn't matter which. I'm just going to go with the 6x minus 8 equals 13 minus x. It's the two I saw. It's what I'm going to do. So I'll take this x over and make it 5x. Oops, make it 7x. Because when I take that x over, it's a minus right here. So it's going to be plus. Take the 8 over, it'll also be plus. And so x is 3. Which that's what that says. That's what those two say. X is 3. But then he asked me to find the measure of each side. So when I put the 3, in here, I get 18 minus 8, which is 10. When I put the 3 in here, I get 7 plus 3, which is 10. When I put the 3 in here, right, I get 13 minus 3, which is 10. So all sides are 10. Answer is C. You got to watch the way they write these answers. They'll trick you. A is not the answer. C is the answer.